Okay, here's a very important proposition is that when you have any triangle, so let's say you have a triangle like that, and you extend it. Now, go back to okay. Now this angle is called exterior angle. Now any angle inside is called the interior angle. So the theorem says that, let's say this is our A, B, and C. And the theory, the proposition basically says that this angle is bigger than this and bigger than that. Good?
Yep.
So basically we're saying B, C, let's put another point, it's D. So this angle, BCD, is bigger than either angle B and also BCD is greater than angle A. Now, if you look at it, it makes sense, right? Good?
Yeah. Right.
But how do we prove that? This actually is a very important theorem with triangle. Is that an exterior angle is always bigger than the two opposite interior angle. Now, to prove it, of course, we have to use construction. So do you remember how to find the middle point of a line?
Yes.
Okay, very good. Any basically any point, any line, if it's a line segment, find the middle point. Okay. So I'm going to show you that how we do that. Okay, let's do that. We got line segment. Okay. The way we do that is actually draw two circles at the same radius. And move that thing. Go to move it. I know there is a way to move this. So this line is outside. Okay, let me actually, I know there is a way to move it, but just pick it here. Okay. So all we're going to do is we're going to draw two circles. And now we find the intersection of the two circles. And we just connect the line. And then this point will be exactly the middle point. Good?
Yep.
Okay. So that's what we're going to use. And you can see that the whole thing is built on top of each other. Okay, we're going to find a middle point. We're going to find the middle point somewhere here. Okay.
Yep.
Okay, so we're going to use that. Do two circles. Now we can connect them. One point, another point. Good.
Yep.
Now I find the middle point and the exact middle point. Let's clean up all that. So once we have that, we can just hide our circles because we don't really need that. Those are just kind of help us to really find this middle point. Once we got that, then we can draw a circle, use this point at the center, and use the other point as a radius. And then we're going to connect these 2 points and extend it. And now we're going to make another triangle. Okay. So basically what we are trying to say is we know this angle and that angle are congruent, right?
Yep.
That's the vertical angle. And we know this line and that line are congruent. Good?
Yep.
So we got A, B, C, this is D. This is E, right in the middle. So we say AE is congruent to DE. Why is that?
Because they're both the radius of the same circle.
Right, they are the radius of the same circle. So we have, and also we know this and that are congruent, right?
Yep.
B and that is C are congruent, because that's what we did. This is the middle point, right?
Yeah.
So therefore it has to. So therefore we got side, angle, side. Good?
Yep.
Then we have two, right? Two congruent triangles. And you see that theme happens over and over, is we're trying to find, trying to make congruent triangles. And then we use that to prove something. So we go triangle ABE is congruent to triangle D, C, and E. Good.
Yep.
Now, if that is congruent, so therefore this angle and that angle has to be congruent, right?
Yeah.
Because that's congruency of triangle. And now we know this angle, which is our, let's put another one here, A, B, C, D, E, F. We know this angle, B, C, F, which is exterior angle, that is bigger than the angle DCE, right? Meaning this angle is bigger than that angle, right? Good?
Yeah.
And we know that DCE is equal to what? Congruent to this angle is congruent to that angle. So DCE is that they are, which is angle B. Good?
Yep.
Therefore, we prove that this exterior angle is greater than angle B. Good?
Yep.
So that's our first proof. And then we're going to use that to prove that the exterior angle is bigger than A. We're going to do the same thing, but we're going to do the other side. Good?
Yep.
Okay. Let's clear that. I'm going to clear here the whole thing. This we can hide. Actually, we can just, yeah, we can hide it. All right. We can hide this line. We don't need that anymore. Okay. Now we're going to do same thing, but it's on the other side. So remember, when we're trying to prove, this angle is bigger than that, we pick this line. Okay.
Yep.
And so basically, this angle to the one side. So in order to prove this one, then we have to use this line. Good.
Yep.
So let's do that. we could pick same thing. And we find the line, connect them. And therefore we find our middle point. And then we're going to extend it. Let me clean up, hide that. Okay. Then we're going to extend it. This at the center, this as the radius. And we're going to draw a line array from here to here. Good.
Yep.
And then we're going to do from here to here. Okay.
Yep.
Now, there is one more thing we need to do is we're going to extend this side. Okay.
Okay.
And you'll see why that. Okay, we don't need this anymore. We don't need that. Hide it. Good.
Yep.
So we go RA, B, C. This is our D, and this is our E. And we pick up 1 point here, 1 point here, A, B, C, D, E, F, G. Okay, just for way to actually identify where is the point, the angles. So now we know this line and that line are congruent, right?
Yep.
Because that's the radius of the same circle. And we know this and that are congruent. AD is congruent to CD because that's, we thought this is the middle point. And then we know this angle and that angle are congruent because those are the vertical angles. So we know ADB is congruent to CD. So therefore we have side, angle, side. So now we know two triangles, ABD is congruent to triangle CDE, right?
Yep.
So now, if that's the case, we know this angle has to be congruent to that angle, right?
Yeah.
And so we know ECD is congruent to angle A. But we also know this angle, which is ACG, like this angle, is bigger than ECD, right?
Yep.
So this angle is bigger than that angle, and also know this angle congruent to A. But what about ACG? Now, ACG is a vertical angle of BCF, right?
Yep.
They're vertical angles. So therefore, BCF is greater than angle A. Good?
Yep.
So now we prove that the exterior angle is bigger than B and also bigger than A. Good?
Yep. Mm-hmm.
So, and you can see it's actually one of the power of the geometry is because we don't have any measurement in the geometry, the triangle. It could be any shape, right?
Yeah.
So therefore, what we proved that is universal. That applies to any triangle. Good.
Yep.
So that's a nice thing about geometry is that once you prove it, it applies to all. And that's what they are the ancient Greek are trying to do. They are trying to find the universal truth, and the geometry is a tool for them to find universal truth. So we have this one very important theorem, and that help us to find to do parallel lines. We actually, there is, okay, let's do 2 lines. We got 1 line here, and we find the parallel line. Fortunately, the modern tool, we can, this is called transform. We can actually translate that to any points. Okay. Okay. Choose a point from to point to, choose what we transfer, apply. So, good.
Yep.
That's the power of modern tools. Of course, in ancient time, it takes a long time to do this. Okay, so this theorem says that if you have a parallel line and you put a transversal across that, and they call it the alternate interior angles are congruent. Means this angle and that angle are congruent. Good.
Yep.
Now, how do we prove that? I mean, it looks obvious, but we still have to prove it. And when we prove it, we say that it's based on either the 10 axioms or previous theorems. Good.
Yep.
So in geometry, we call it proposition. Proposition, it means that something we have not proven. It's a true statement. It says something is true, but it has to be proven. But once we prove it, proposition become theorem. Good.
Yep.
So theorem basically is a proven proposition. So because it's a proven, we can use the previous theorems. Good.
Yep.
So basically, we're building in a way, we're building a hierarchy. We have the 10 maximums as our foundation. And then on top of that, we have theorems. Then we can build on top of each other. Good.
Yep.
And eventually, we're actually building something like inverted pyramid. That theorem become more and more on top of that. Good.
Yep.
Okay. So let's do the proving. Let's say this is angle 1, this is angle 2. We're saying that if the line, so this is say L1 and L2, if L1 is parallel to L2, then angle 1 has to be congruent to angle 2. Good.
Yep.
So here's the proving. We're going to use the previous theorem we just proved that exterior for any triangle, the exterior angle has to be bigger than the opposite 2 interior angles. Good.
Yep.
Okay. So here's a very, very common technique is to assume something is true and then we'll find the logic contradiction. So basically, instead directly proving the theorem, we basically say, okay, what if L1 is not parallel to L2? Now, of course, given still these two, they are the same. So if it's not parallel, what happens? Then this line eventually will, and that line eventually will meet, right?
Yep.
So it's kind of very, very narrow and very long triangle, but still it's a triangle, right? Good.
Yeah.
No, Bryce doesn't understand.
I got confused for a second. Sorry, I got it.
You got it?
Yeah,
So,
sorry.
so basically we're going to say, okay, what happens if it's not parallel? Because we're saying that if the parallel of the two angles has to be the same. So we say, okay, well, we have two angles the same, but not parallel. What happens then? And then we know that L1 and L2 will meet, right?
Yeah.
I mean, it may be very long. Kind of, I was here is kind of with drawing is bended, but you have to imagine these are straight lines. Just like I won't be able to graph it if it's truly straight. But you can see that eventually they have to match, right? Have to intersect. Good.
Yep.
Okay. That means what? It means we got a triangle, right?
Yep.
Now, if it's a triangle, what happened to this angle with relation to that angle? Then we know this is exterior angle. So angle 1 has to be greater than angle 2, right?
Yeah.
But we just said angle 1 and angle 2 are the same, are congruent. Good.
Yeah.
So we came to a logic contradiction. Now, how do we solve the logic contradiction? Is that means whatever the premise is not true. Good.
Yep.
So therefore, L1 and L2 have and must to be parallel to each other. Good.
Yep.
Because if not, when we get into this weird, we got the contradiction that angle 1 is bigger than angle 2, but we said angle 1 and angle 2 are congruent. Okay.
Yep.
Yeah.
So that's actually a very typical way of proving is instead of directly proving it, we just say doing a what if that is not true, and then we'll get to a logic consequence, and then if we find there is a contradiction, then we know it has to be true. Good.
Yep.
Okay, so we got that. And then the last theorem is the other way around. We don't have to prove it, but you can do it. I mean, you don't have to. Okay, let me go back to construct a new one. Okay, so that is basically the other way around, is that so the previous theorem, we said that if two parallel lines and have a transversal, then the alternate interior angles has to be congruent. And this time we're going to the other way around. We say, okay, if there is two lines, and if there is transversal, and if angle 1 and angle 2 are congruent, then the line L1 and L2 has to be parallel. Good.
Yep.
So it's other way around. The one we put earlier is said if L1 and L2 are parallel, then angle 1 and angle 2 has to be congruent. Good.
Yep.
Now we are saying if the other way around, if angle 1 and angle 2 are congruent, then L1 and L2 must be parallel. Good.
Yep.
Okay, so that's what we have for today. Any question?
No.
All right, so I'll see you next time. Okay.
All right.
Bye.
Bye.
Yeah, make sure you know how to bisect the line, okay, or find the middle point. Good.
Yeah.
Bye.
Bye.